Find the derivative of y is equal to 1 over x from first principle. In our previous questions, we deal with the question we were given is f of x is equal to x squared. And in our previous lesson in functions, we talk about what a function is, and also it can either be the f of x, function of x we can also write it as y, either this or this. They are the same thing. We have explained that in our previous lesson. Now, this f of x is equal to x squared. You can also rewrite it as y is equal to x squared, because this y and f of x, they are the same thing. Now, in this question, we are given y is equal to 1 over x. So you can also rewrite it as f of x is equal to 1 over x, because the function of x, which is f of x, is the same thing as this y. They are the same thing. Now, what is the meaning of this 1 over x? Y or function of x? Y or function of x? Why is it 1 over x? But before that, let's write out our formula, our differentiation from first principle formula. In our previous class, I intentionally used m as a gradient. So, but now I write it as m is equal to change in y divided by change in x, which is y2 minus y1 over x2 minus x1. So, and which is the same thing as f is bracket s plus change in x plus x, yes, plus f of x plus f of x. Let me write it, sorry, because of the space, which is also the same thing as f into bracket x plus change in x, yes, minus y. Our minus y1, our y1 is f of x, and don't forget this is our y2 minus y1 divided by x2 minus x1, which is change in x. So this is the gradient function formula. It is also the derivative function formula. I just intentionally write the gradient function formula. I intentionally write it in our previous question because we just get started that time, so that it will be easier for us to understand. But now we are going to return what we are going to return something that is what we are going to return a thing to its rightful owner. Yes, let's do it like that. So m will now change to what? Our derivative functions. This is no more gradient function. We are talking about derivative function, which is dy over dx. You can write it as f prime x or d over dx f or df over dx, anyhow out of them. So, but here I'll be using dy over dx. So dy over dx is equal to f into bracket s plus changing x minus f into bracket x divided by changing x. So this is the parameters we are going to be using now. This is the correct form we're supposed to write, but because in order for the work to be more easier and simpler for us, that's why I use m that time, because they are the same thing. But the difference between them is that this dy dx, it has a limit. The limit when our x is approaching 0. That's the difference there. So now let's treat this question. Let's treat the question. Let's go straight to the question and treat it. So now our y dy over dx is equal to f into bracket x plus change in x minus f into bracket x divided by change in x. Now, but the equation that we are given is y is equal to 1 over x. It can also be we can also write it as f of x over is equal to 1 over x. They are the same thing. If you remember, I drew something like this in our previous lesson. So I use mapping as an example, so that this is our x, this is our y, this is the domain, and this is our codomain. So the function of x will give us this y. This function of x will give us the value of y. So any number that is written here is function of x. That means function of x is also the same thing as y. Kindly go and check our previous video on functions. So now let's continue our work here. So now this f of x is equal to 1 over x, or y is equal to 1 over x, anyone. This 1 over x, it implies that, it means that what is stored inside this function is what is inverse of x. It is 1 over that functions. For example, if it is f over 2, it means 1 over 2. It is the inverse. What's the meaning of inverse? The inverse of a is 1 over a. The inverse of b is 1 over b. The inverse of 100 is 1 over 100. The inverse of 1 over 100 is 100. The inverse of 1 over a is a. So inverse is 1 over something. So now the inverse, what this question implies, it implies that what it means that this 1 over x, this 1 over x, 1 over x, the inverse of x, that means whatever you input here is the inverse of that function. Whatever you put inside this function is the inverse of that function. Either it is f bracket x plus change in x, it will change to what? 1 over x plus change in x. If it is f in bracket change in x, it is 1 over x. We have explained this in our previous class when we are dealing with the first question on derivative of principle. When we are given f of x equal to x squared, we have done this. We have explained this in our previous lesson. So kindly go and check it. Now that means any variables or any input that is inserted here, is a reciprocal or is an inverse of that input. This is what is going to give us. So therefore, we are going to do the inverse of all the inputs. So now if we check this question very well, so how we're going to do it is, now we are going to f this our y2, this our y2, this our y1, and this our change in x, which is x2 minus x1. We already know this. So now what we are given is 1 over what is stored inside the variable, and what is stored here is x plus change in x. So we are going to do the inverse of it. We are going to divide 1 by 8, because that is the interpretation of 1 over x. So therefore, this f of x plus change in x, so our f of x plus change in x, which is our y2, is now 1 over x plus change in x. Also, our y1, which is f of x, is now 1 over x. But we already know that our change in x is the same thing as our change in x. No need of disturbing ourselves about that. Now let's insert all this inside the formula. So now our y2 has now become 1 over x plus change in x minus f of x is now 1 over x. Everything divided by change in x. So don't forget, these are y2, these are y2, these are y1, and these are our change in x. So now what's there is that we are going to solve the numerator first. Let's first solve the numerator. So 1 over x plus change in x minus 1 over x. So now let's find the LCM. S plus change in x. So the LCM is this, the LCM. Now this one divided by this. So this one will cancel this. So it will give us x. What remains is x, as in x plus change in x, bracket x, divided by, if we divide this by s plus change in x, we are going to cancel this. So what will remain? The answer here is x. So now that s, you are now going to multiply by 1. It will be x minus this LCM divided by x. If we divide it by x, s plus change in x, x divided by x. So what remains is s plus change in x. If you multiply this s plus change in x by this one, it will be the same thing as x plus change in x. Now, what we are going to do now, what we are intended to do is to find the numerator. So now the numerator is now x minus, we are going to open this bracket, minus x, minus times plus is what? Minus change in x, divided by x plus change in x, x. Now let's, this one, s minus x is 0. The answer here is minus x divided by s plus change in x, x. So this is the value we got. And don't forget, there's plus here, but it is invisible. We already know if you said 2 plus 2, so it is 4. Don't forget that there's a plus here which is invisible. If you said 2 minus 1, 1, there is plus here that is invisible. Likewise, there's plus here that is invisible, but this minus s, there's no plus here. It is either it is plus or minus. So it won't be 2. Now it is 1, it is minus here. So this one did not add anything. That means it is automatically plus. If we divide minus by plus, it will give us minus. So therefore, our answer here is the numerator. The numerator is what? Minus divided by plus is what? Minus x over x plus change in x bracket x. Now, let's divide it with the denominator, which is our change in s. Let's go back to our dy dx is equal to what? X over x plus change in x be minus x divided by what? Divided by this change in x, divided by change in x over 1. So that is the interpretation of this. That's the interpretation of this. So the value we get here, we are going to divide it by change in x, and the value we got in the numerator is minus s over s plus change in x divided by x. We are now going to divide it by what? By our x. We are now going to divide it by our s divided by x. Now, so it will now be minus x over x plus change in x, x. This division, so in the rules of division, we change it to multiplication. The numerator will now change to denominator. Why the denominator, which is 1, will change to numerator, while the numerator will change to denominator. So therefore, we now multiply together. So minus x times 1 is minus x divided by, so it will now be minus s times 1 is minus x over s plus, it will now be this s, let's move it here, x into brackets plus change in x. This s, we are moving to this side. So times this, everything here times this change in s. So that's it. But don't forget, in our in the formula of derivative functions that give us dy over dx, dy dx is given as f of x plus change in x minus f x divided by change in x when the limit of x is approaching 0, when the x is approaching 0. So therefore, since our change in x, since our change in x is approaching 0, that means all this value of change in x, we are going to what? We are going to turn them to 0. We are going to turn this to 0 because the moment, if you remember, if you recollect, so the moment this is point B, this is point A. The moment the slope of this point B move to point A, our change in x we tends to 0 here. We turn to 0. We move closer to 0. So, and it has happened here. So, therefore, our change in x, all our change in x here is 0. So, now the variables, the answer, the result we got from this formula is this. So, now let's write it out. So, dy dx is now minus x over x plus change in x. So now our change in x, but our change in x is now equal to 0. So therefore, minus x over x into bracket x plus change in x times 0 and 0. Our change in x here, they have turned to 0. So it will now be minus x over x plus 0. X plus 0 is 0. Oh, sorry, I've made mistake. Okay. Now, sorry, we have made mistake. So if you recollect from what we calculate here, it is minus change in x. It is minus change in x, not minus x. It is change in x. I will change it. So it is change in x. Change in x is a mistake. So sorry. So it will be change in x. Yes. So we have corrected. Now let's move on to our work. So now, so this one will be minus change in x. So, and also this, it will be minus change in x. Yes. This one will also be what? Minus change in x. So now, before we move on, before we arrive at the limit of change in x equal to 0 here, when x approaches 0, we're supposed to what? We're supposed to divide this change in x divided by change in x. So let's correct it here. It's nothing that is very hard. So let's correct it. We are going to break it down. So let's correct it here. So now this is change in x divided by change in x. So this change in x minus change in x will now turn to 1. So now, so therefore our dy dx here, this is the formula, and the result of this is what? Minus 1 over x divided by x plus change in x. Yes, we are done with it. Because this change in x have cut each other. So this change in x here will turn to 1. So they will cut each other. Now, this is our what? This is our value for the derivative function. Now we are now going to move on to the limit. So the derivative dy dx, when x is approaching 0, it will be given as f into bracket s plus change in x minus f into bracket x divided by change in x. So now this is the value we get for the formula. So now that means all our change in x here, we are going to turn them to 0. So the answer is 1 over x is bracket s plus change in x. So this place is no more useful. So let's delete it so that it won't mislead us. So now it will now become minus 1 over x into bracket s plus change in x when our x is when our change in x is approaching 0. If our change of x approaches 0, so that means our change in x will become 0. So from that, so we are now going to what? Make the change of x to be 0, because here now the change of x has approached 0 since our what? Since our gradient or slope of b has moved towards point A, it has moved closer to A. So therefore, our change of x with tens, or we move closer, we turn to 0, we move closer to the value of 0. So therefore, x is bracket x plus, this change of x is now 0. So, which is now minus 1 over x into bracket x plus 0 is what? X. So, which is what? Minus 1 over x times x is what? X square. So, this one is minus, and what is here? We already know that it is plus. Why is it minus 1 over x square? Let me work it out here. It's very simple. So, minus 1 over x into bracket minus 1 over x square. Sorry. So, don't forget that this x square, it has addition. This one, it has subtraction, minus. Minus divided by plus, it will give us what? Subtraction. It will give us minus 1 over x squared. So that's how we arrive at this. So therefore, our answer, so for the derivative functions, so the derivative of y is equal to 1 over x, that is dy dx of 1 over x. So when you can also write it like this dy dx, you can also write it like this, change in y over change in x, still the same thing. So, but I like writing like this, dy dx, when the limit is approaching 0, when the x, sorry, where the x is change of x, when change of x is approaching 0 is what? Is equal to 1 over x square, sorry, minus 1 over x square. So this is the answer. You can also write it like this, f prime x is equal to minus 1 over x square. Still the same thing. This is also, you can also either denote it as dy dx or f1, f prime x, or the d dx f, still the same thing. Anyhow, you can write it, or you can also write it like the f over the x, still the same thing, minus 1 over x square. Everything is represent the same thing. So our answer is minus 1 over x square. So that's the answer.